Hey everyone, welcome back. Alright, let's get right to it. We're going to set up data source and connection pooling in Spring Boot. We'll get our database connection going, change some pooling settings, and show you how to get a connection object super easily.
So, let's jump right in.
Alright, let's get things set up properly. We've already built our DAO module, but here's the thing, we're running our API module, and without linking the DAO module, our database operations won't work. So, what do we need to do?
Simple.
We need to include the DAO module inside our API module.
And how do we do that?
By adding it as a dependency in our API module's pom.xml. Now, let's apply the changes in our API module's pom.xml. Just follow along and do exactly as I do on my screen. Reload the Maven changes. Open the application.yml file where we define our database settings. Alright, first up, we need spring.datasource.url. You know, the URL format is just like last time. So let's add it now and make sure it's pointing to the right database. Next up, we need spring.datasource.username. This should be the same user you use to log into your database, and make sure they have the right permissions. Alright, now we need to add spring.datasource.password to ensure our application can authenticate with a database securely. Alright, one more thing we need to add. Spring.datasource.driverClassName. This tells Spring Boot which driver to use to talk to our database. Since we're using MySQL, we'll put com.mysql.cj.jdbc driver here.
Great.
Now that we have our database connection basics set, let's get into making our connection pool run even better. Like we talked about, Spring Boot uses HikariCP, which is already really good. But we can change some settings to make it even faster. Let's define our connection pool name using spring.datasource.hikari.poolname. I'll set it to Employee Service Connection Pool, as you can see on my screen. Okay, let's set spring.datasource.hikari.minimumIdle. This is how many connections should always be ready and waiting. Since we're just testing this out locally, I'm going to set it to 3. This means we'll always have at least 3 connections ready to go, so things don't get slowed down. Next up, let's set spring.datasource.hikari.maximumPoolSize. This is the most connections we want to have at any one time. I'm going to set it to 5 for now. Next up, let's set spring.datasource.hikari.idleTimeout. This is how long connections can sit around doing nothing before we close them. I'm going to set it to 600,000 milliseconds, which is 10 minutes. And don't forget, this setting is in milliseconds. Alright, now we're going to set spring.datasource.hikari.maxLifetime. This is how long a connection can live before we make a new one. I'm setting it to 1,800,000 milliseconds, which is 30 minutes. And just like before, this is in milliseconds.
Alright.
Let's talk about spring.datasource.hikari.leakDetectionThreshold. This setting is like a warning system. If a connection stays open too long, HikariCP will tell us about it, so we can fix potential connection leaks before they cause trouble.
But watch out.
You need to set this based on how long your database queries usually take. If it's too short, you'll get a lot of false warnings, and if it's too long, you might miss real problems. I'm not setting it right now, but it's a really useful tool for finding bugs in real applications. Next, let's configure spring.datasource.hikari.validation timeout. I'm setting it to 5000 milliseconds, which is 5 seconds. Whenever HikariCP validates a connection, like a health check before handing it over to the application, it will wait for a maximum of 5 seconds before deciding that the connection is invalid. Alright, now we're going to set spring.datasource.hikari.connection timeout. I'm setting it to 30,000 milliseconds, or 30 seconds. This is how long we'll wait for a connection before we give up and show an error. Basically, if all the connections are busy, new requests will have to wait. If they don't get a connection within 30 seconds, we'll throw an error. It's a way to keep things moving.
Alright.
Our configuration is complete. Now, let's test if everything is working seamlessly. First step, open the DAO module's pom.xml file. Next, we need to add the Spring Boot Starter dependency. This is so we can use it autowired and its service for dependency injection. If we don't add it, our service classes won't work right, and it autowired won't work either. Now, just do exactly what I'm doing on my screen. Now, let's open our main class file. Okay, next step, we need to add its service to this class. This tells Spring Boot it's a service we want to use. Now, let's inject the data source into our service class. Now, let's make sure our connection method runs automatically when the bean is created. Annotate it with @postConstruct. This ensures that as soon as Spring initializes this class, our method runs to verify the data source configuration. Next, let's clean up our method, remove static, rename it for better readability, and remove any unnecessary parameters. Watch as I do this on my screen. Since we've already declared the database URL, username, and driver class in our configuration, there's no need to set them manually in our code. Let's clean this up, remove the redundant declarations and simplify our setup. Also, since Spring Boot handles class loading automatically, we don't need to manually load the driver class. Watch as I clean up the code on my screen. Now, let's add some logs to verify that this method is actually being called. Now, let's replace driverManager.getConnection with datasource.getConnection, just like I'm doing on the screen. This method fetches an available connection from the pool instead of creating a new one each time. And here's the best part, when we call connection.close, it doesn't actually close the connection. Instead, it returns it back to the connection pool, making it available for the next request. Alright, let's start our employee service application. Now, let's check our console logs to verify if everything is working correctly. Oh, our logs are missing. That means our bean might not be created. But don't worry, let's debug this together. Let's get to the root of the problem. Open the Employee Service Application class. Now, look at our package structure carefully. Our Employee Service Application class is inside com.gan.derpun.employee, but our service class is inside com.gan.derpun. It mean base package for scanning is com.gan.derpun.employee. Due to this, the service class present inside com.gan.derpun is not scanned. Let's fix this by adding scan base packages in at Spring Boot application annotation. Now, restart the application again. Alright, check this out on my screen. This time, we've successfully retrieved all user details from the database.
Look at that.
That means our data source configuration is working perfectly. No manual connection handling, no hassle, just smooth, efficient connection pooling. In this video, we successfully configured our data source and connection pooling in Spring Boot, ensuring optimized database interactions. But we're just getting started. In the next video, we'll take it a step further and use Spring JDBC template and named parameter JDBC template to build our GetEmployee REST API. We'll apply our knowledge to build real-world applications. Stay tuned, it's going to be exciting. Don't forget to like, subscribe, and hit the notification bell so you don't miss out. We're building something amazing together. See you in the next one.